Good morning. This is Mrs. Coleman, and I am going to go over a lesson with you entitled Power of a Product Rule. So, what I'm showing you on my computer screen right now is the summary of the exponent rules. It's in a chart, and so I will include the chart with this lesson also. So, we're going to focus in on this one right here. So, what this is telling us is if we have two bases that are raised to the same power, then we can take each of those bases to the power on their own. So here's an example of xy to the fifth power can be treated as x to the fifth times y to the fifth. Our paper that we're going to look at today is actually going to put this in reverse. We're going to look at some bases that are different. The exponents are the same. We're going to talk about how we can get them in this form. So this is the sheet that is included in your lesson today, and this is just the one that we're going to use as an example. You'll have two papers that follow that will be very much like this. So as we look at problems 1 through 6 in part A, notice that the bases are different. Those would be the bigger numbers here and here, but the exponents are the same. So what we're going to do is we're going to take these two bases and we're going to multiply them together. So I have negative 4 times negative 12. And negative 4 times negative 12 is positive 48. When we write our answer, though, it asks to use the power of a product rule to rewrite each expression as a single exponent. So we also do want to include that exponent. Question number 2. Again, bases are different, and this time the bases are fractions, but those exponents are the same. So we're going to go ahead and multiply those bases together. So I have negative 1/6 times 3 over 2. Many different ways to multiply those fractions. You could do some canceling as you move along, or we can just simply multiply straight across the top, straight across the bottom, and then simplify in the end. So that's what I'm going to choose to do. So we have negative 1 times positive 3 is negative 3, and 6 times 2 is 12. And when I simplify that, I have negative 1 over 4, and that's because I can divide 3 and 12 both by 3. So this is going to be my new base. Ran out of room for my answer. So here's my base, and then I'm going to be using the same exponent that's there. Some of these will show negative exponents, and for our purposes right now, just go ahead and leave them as negative. We'll take care of that in a different lesson. Question number 3. We have negative 7.2 to the 14th times 6 to the 14th. Here's our bases. There are those identical exponents again. So we're going to multiply these two bases together. Negative 7.2 times 6. And so that's going to equal negative 43.2. All right, so if you need to see the work for that, I'll just do that in the corner, but it's okay to use a calculator if you need to. So 6 times 2 is 12. Carry the 1. 7 times 6 is 42, plus 1 is 43. One decimal place in my answer, and my final answer needs to be negative. So for my answer that goes here, we do need the base of negative 43.2, but we also need that exponent that was shared above. Okay. For question number 4, again, we look at those bases. They are different, but the exponents are the same. So the product rule tells us that we can go ahead and multiply those bases together. So 9 times 8 equals 72. And so my answer will be 72 to the negative 12th power. Question number 5. Again, we've got those bases that are different, but those exponents are the same. So we can multiply these bases together. Okay, and again, you can use a calculator if you need to. I'm going to go ahead and multiply them along the side here. 4 times 5 is 20, carry the 2. 4 times 5 is 20, plus 2 is 22. 1 times 5 is 5, and 1 times 5 is 5. Add these together, we get 770. There needs to be 2 decimal places in my answer, so my decimal point's going to go there. One of my numbers was negative, so my answer for this will also be negative. So my base of negative 7.7 and my exponent of negative 8. Question number 6, still in part A. Again, we've got the bases of negative 3, negative 4/3. We've got those matching exponents. So we're going to go ahead and multiply those bases together. So negative 3 times negative 4/3. Now, in order to make this a little bit easier, I'm going to go ahead and write that negative 3/1. Make them both look like fractions. So if I have negative 3 times negative 4, I have positive 12. 1 times 3 is 3, and 12 divided by 3 is 4. So my base is 4, and my exponent is 2. Part B. For these series of papers that we've been working on, the Part B area has caused some of you some problems because you're not taking the time to write equations out. So it's the same type of work. Oops, sorry about that. Let's see if we can get that focused in a little better. Okay. So we want to make sure we're doing the same thing that we're doing above. So if I kind of put number 4 from above in the picture, we multiplied those bases together. So down here, we don't know what this base is, but I know if I take this times this base, I want this as my answer. So I need to write an equation for that. So I have x times 6/7 equals negative 6. So I need some number times 6/7 to get negative 6. So one thing that you could do, because this is a fraction, a couple different things you could do actually. One is you could divide both sides by 6/7, or you could multiply by the reciprocal of 7/6. So I'm choosing to multiply by 7/6. I'm going to put a little 1 underneath it there. On the left side, the 7s are going to cancel and the 6s are going to cancel. And on the right side, I'm going to go ahead and cancel the 6s. Remember, if there are matching numbers in the numerator and denominator, you can just cancel them. So now, it's like taking negative 1 times positive 7 to get negative 7. Excuse me. And in the bottom, it'll just be a 1, so we don't really need to show that. So this is my base that's being asked for. So that's the only thing that is being asked for. So I'm just simply going to put a negative 7 in there. Okay. Question number 2 is just asking me for the exponent. So remember, all the way through those exponents must match. So this is just going to be a 6. Needs to match this and this. Okay. Question number 3. I need to figure out what this base is. Now notice it says negative x there. Some of you are struggling with that negative x, but here's my setup. 3.1 times negative x equals 6.2. To get x by itself, I'm going to do 2 things. First, I'm going to divide by 3.1. Okay, and when I do that, 6.2 divided by 3.1 is just a 2. But on this side, x is not quite by itself yet. It has a negative sign in front of it. So to take care of that, I'm going to divide both sides by negative 1 to get x equals negative 2. Okay, so x needs to equal negative 2. So we will put that in place of x, negative 2 for x, times that negative 1, that's going to make it positive 2. Multiply that with the 3.1, you get 6.2. Question number 4. Again, we're looking for that base. So I have negative x times 1.5 equals negative 1.8. Okay, so I'm going to divide by 1.5. And again, it's okay to use a calculator if you need to. I'm going to go ahead and put my work over here to the side. I'm going to do a little bit of long division. So for long division, we don't really divide by decimals, we move them. So my decimal is going to go right there. 15 goes into 18 one time. When I subtract, I have a 3 left. I put a 0 here, bring it down. 15 goes into 30 two times. So I get 1.2, but I did have a negative. So I have negative divided by positive, so I'm going to have a negative 1.2. Negative 1.2. Okay, so that's for the right-hand side, negative 1.2. But look at what's left on the left-hand side, negative x. So x is not quite by itself yet, and again, I need to divide by negative 1 to get x equals 1.2, positive 1.2. Okay. All right, question number 5. We have negative 2/3 to the 13th, x to the 13th equals 1/2 to the 13th. So we need to figure out what's going to go in for x. So I have negative 2/3 times x equals 1/2. So this is very similar to question number 1 in this section, where because I'm going to divide by a fraction, I'm going to go ahead and multiply by its reciprocal. So I'm going to multiply by negative 3/2. Those will cancel, those will cancel. So I'm going to do the same thing over here. I don't have anything that will cancel this time, so I have to go straight across top, straight across the bottom with multiplication. 1 times negative 3 is negative 3, and 2 times 2 is 4. Okay, so we get negative 3/4. X is by itself over here, so that's my answer. Okay, question number 6. We've got those matching exponents again. So we need to take x times 4 equals 40. Divide by 4 to get x equals 10. So fairly easy one for this problem. Okay, and then part C, multiple choice, but still the same idea. So this is going to match what we saw in part A. So we have those bases that are different, those exponents that are the same. So we're going to simply multiply those bases together. Okay, and if you'd like, you can multiply straight across the top, straight across the bottom, or we can do some canceling there. It's completely up to you. So I'm going to go ahead and multiply straight across the top. 9 times negative 2 is negative 18. 2 times 3 is 6. And then I'll divide 6 into negative 18 to get negative 3. We are going to express our answer using the exponent of 15. So I need negative 3 to the 15th power. And we see that in choice number 2 right here, Roman numeral 2. Okay. And then our very last problem will mimic what we saw in part B. So we have those exponents that match. So with my bases, I need some number times 8 to get 64. So we're going to divide both sides by 8, and we'll get x equals 8. And so our choice for that one is going to be Roman numeral number 1. Okay. So when you get ready to do your assignment, it will be very much like this. So please take the opportunity to check this out. Have a great day.